Well, welcome everybody from beautiful Mr. Wheeler's classroom. They're doing some construction in my room, cleaning floors and taking down some lights and whatnot. So they asked me to leave. So I'm kind of adjusting to Mr. Wheeler's classroom for a little bit. So I feel a little bit out of my element. Some of the stuff doesn't work quite the same in here. So hopefully this goes smoothly. But right now, I'm hoping to take a look at a couple of questions, one in this video, one in another video, talking about solving some differential equations. Now, this is stuff I want you to know. I know there's definitely one piece that will not be addressed on the AP test because it's just kind of honestly too simple for them to invest that time, but it's okay, we can actually take a look at that. We're going to be taking a look specifically at the 2018 question number 6. And so here we go. Let's go ahead and open up that dot camera. So this is the question right off the bat that I don't think they're going to invest time in. And they're asking us to just, can you go ahead and do a quick slope field around the point 1, 0, which is sitting right here. So, if you were to just kind of follow that in, it looks like it would go like this. And you can also see that there's some nice symmetry. So it's going to hit here on this other side as well. Probably dip down in here somewhere, come back up and exit right here. This is a pretty typical problem on AP tests, but pretty simple, not worth a whole lot. So I'm not overly worried about that question. But when we get to question B here, that's where we start actually dealing with some stuff. So they're asking that. So they're saying let y be the particular solution to this differential equation with this coordinate right here, and they want me to write the tangent line. Well, every time for the last quite a while that we've done a line, we start here with this idea right here. And of course, instead of calling it y, I'm going to call it f of x because that's specifically what they have asked me to do. So I'm going to call this f of x minus the y value. Now keep in mind this thing right over here says 1, 0, which means if I plug in 1 for x, I get 0 for y. So I've got this right here. Looks like that's the 1. But then what I need to do is figure out the slope. But the cool thing is in this problem is they told me that the slope dy dx is a third of x times y minus 2 squared. So if I took dy dx and I evaluate that at the value x comma y being equal to 1 comma 0, that would be a third of course, this is telling me that x is 1, and this is telling me that y is 0, so 0 minus 2 squared. I just got a nice simple value of 4/3. So that's the slope that I have for this particular problem. So f of x minus 0, which of course doesn't really do much, is 4/3 x minus 1. Now that actually gives me the first portion of that story. This is write the equation of that tangent line. Now this is question 6, which means we can't unfortunately use it to check our answer, but we know that that's okay. And then they want to use this to approximate something. Now keep in mind that if you were to look at the story that we have, if you were to make the line right here tangent at 1, 0 coming along like this, and try to use that to approximate what happens at point 7, you'd know that it's curving away from that line, so it's not going to be perfect. So we're going to say f of 0.7 is approximately 4/3. Now keep in mind that I'm using this equation at 0.7. And so I've got 4/3 of negative 0.3. And yeah, I know this is not a calculator allowed question, but of course we would know that 3 goes into their 0.1 times. So it appears that that answer should be about negative 0.4. Now that's not the exact perfect answer for that evaluation, but it's very, very, very close. And so now we can actually look at the very last part of that question, which is actually the harder part of that question, which is to go ahead and find a particular solution given this initial condition right here. So what I want to do is start by writing that dy dx is 1/3 of x and a y minus 2. Now, the most significant step of this particular problem right away is to go with that separation of variables that we've been practicing a little bit. So I'm going to divide this y minus 2 squared to the other side. So I've got y minus 2, that doesn't look good, y minus 2 squared dy, and I'm going to move this dx up here to this other side. Now, that actually is just a case of being able to separate those variables. We want to go ahead and integrate both sides, but it is honestly a little bit easier to look at this particular problem as more of a power rule. So instead of thinking about it as over x squared, think about it as to the minus 2. Remember that constants can come in front. And so, of course, power rule says we're going to go up 1, and then we're going to divide by that. Now, we also have, because of chain rule, we have to consider what the derivative of what's inside would be. But in this particular instance, that would just be the number 1. And over here, we're going to have this 1/3, and we have a 1/2 x squared plus c. So we actually have a fairly simple little story right here. Now, that's awesome. That is the general solution, but we don't want the general. We want the particular solution of this thing because we want it to go through 1, 0. So, of course, now what I'm going to do is I'm going to plug in 1 for x. I'm going to plug in 0 for y. So now if I plug in 1 for x, I get 1/6 of 1 squared plus c. Over here, I plug in 0. I have -1 over -2, which is just 1/2. So if I bring this stuff to the other side, what we're going to end up finding is if we have 3/6 minus 1/6, we're going to get 2/6, where c is basically 1/3, which was pretty nice. So now I have this new story because I now know that c is 1/3. But you know, and that's really, really close, except they want me to find y itself, not this crazy thing right here. So we just have a little bit of crazy math to do. The first thing I would do is I think I would go ahead and I think the first thing I'm going to do is move this around a little bit. I'm not really liking this very much. I got this. I'm going to make a common denominator, honestly. Let's make this 2/6. And therefore, I can multiply both sides by -1. Then I can take the reciprocal of both sides. That's actually a kind of a slick thing to do. I'm going to take the reciprocal of both sides. And then, of course, all that would be remaining for me to finish is to move that 2 to the other side, and we now have isolated that particular problem for y. And arguably, for me, I think this part is probably the toughest part of this question, was just the old algebra 2 going about solving that problem. I hope that actually makes sense, and I hope that was a fairly successful problem for you, not overly difficult. We'll be trying another one of those in a moment. Hey, I'm glad I got to share a little bit with you, and we'll see how it goes.